Here's our last example of a series parallel circuit. So if we look at this one, now this one's a little bit different. This is the same example that I used in the PowerPoint, but this one is drawn just a little bit different, but don't let that throw you. We come out of the battery, we go through this resistor right here, so it's in series with the entire circuit. We come to this point, the voltage splits, and it comes down this parallel leg and this parallel leg, and these two resistors are in series with each other. These two are actually in parallel. So because you've got a junction here, you got a junction here, so these are in parallel with each other. So the first thing I'm going to do is I'm going to fill in my known values. So that's 12 volts here, and I know what my amperage total is, which is 4 amps. And I know what almost all of my resistors are. This is the answer we're looking for, is resistor number 1. So, but resistor number 2 is 4 ohms. And resistor number 3 is 4 ohms. Resistor number 4 is 8 ohms. And resistor number 5 is 4 ohms. So that's our, those are the values that we know we have. So now let's go ahead and simplify the circuit so that it makes a little bit more sense to us. So I'm going to redraw it. And I'm going to leave resistor number 1 there. And I'm going to combine resistor number 4 and 5. So this is, oh sorry, R2 and R5. And I'm going to redraw this one here so that it looks a little easier. Okay, so I just redrew that one there to look like this because it's basically the same thing. So this one here is R4, and this one is R3, and this one is R1. So this one we don't know what the value is here, but we do know this one is 4 ohms, and this one is 8 ohms. And this one here, because these two are in series, we just add them together, so that's 8 ohms. Okay, so now what we can do is we can combine the circuit again. So I'm going to redraw it again right here. We'll leave resistor number 1 there. So this is R1, and this is R3, and this one is R2, R4, and R5. So that's what I'm going to do here. So this right here, I've got 2 resistors, same value. So I can take these 2 resistors, they're a value of 8, divide it by 2 equals 4. So that's going to be my resistance here is 4 ohms. And this one here is also 4 ohms. So now what I can do is I can simplify it one last time. So this is R1, and draw my dotted line around it here. This is going to be R2, R3, R4, and R5. So that's what these are. And the way I'm going to simplify it is I've got 2 resistors. They're both 4 ohms, and I've got 2 of them. So that's 2. So that gives me 2 ohms of resistance. So I've got 2 ohms of resistance here, and I've got, I don't know how much resistance there, but I do know what my amperage is. If you look over here, my amperage total is 4 amps. And if you remember, on a series circuit, amperage is constant in a series circuit. So if I use that to my advantage over here, this is going to be 4 amps. So now I can figure out what my voltage drop is on all these over here. So if I figure out what my voltage is being used up over here, then I can figure out how much voltage I should have left for this one. So 2 times 4 is 8 volts. Okay? So in other words, I've got 8 volts here. So that's 8 volts here. 8 volts is coming down this way, and 8 volts is going this way. So if I want to write in some values over here, this one's in parallel, this one's in parallel. So I've got, man, I cannot write an 8 today. So I've got 8 volts coming down here, 8 volts coming down here, and 8 volts going that way. So this is all 8 volts. These two are separate resistors, so they're both going to have 8 volts. So R3 is 8 volts, and R4 is 8 volts. These two are going to share the voltage. So these two right here, they're going to share the voltage. So I can't put 8 volts on each one of those yet. So that's R2 and R5. But what I can do is I can figure out how much voltage is left over to go on this one right here. So if I've got 8 volts right here, and I've got 12 volts total, all I have to do is subtract 8 from 12. So if I subtract 8 from 12, so 12 volts is my total, and subtract it 8 volts from it, that is going to leave me with 4 volts. So this resistor right here is going to have 4 volts. So if I come up here to voltage on resistor number 1, it's going to have 4 volts. Now, if I remember my series circuit laws, amperage is constant in a series circuit. So the amperage is going to be the same on this resistor as it is for the resistance total, because it's in series with the entire circuit. So this is going to be 4 amps. So to figure out what my resistance value is 4 divided by 4 is 1 ohm. So that's the actual answer we're looking for, is 1 ohm. And we can continue figuring out everything else to see if we're right on that, just by plugging in the rest of the numbers. So let's go ahead and fill in the values that we know. So 8 divided by 4 is 2, and 8 divided by 8 is 1. So this amps and this amps. And so what we need to do is we need to figure out what our voltage drop is on these two right here. So if we look at this circuit all by itself, so this circuit right here, all by itself, it has 8 volts total, and it has 8 ohms total, so it has 1 amp total. Okay, so, and the way I figured that out is, because these two are in series, I've got 4 plus 4 is 8, so that's my 8 ohms of resistance in total. 8 volts coming down from here, so that's my 8 volts total. 8 divided by 8 is 1. So over here I've got, so this is resistors number 2 and 5. I've got 1 amp total. So now I can just do Ohm's law to figure out the rest of it. So if I calculate this, 1 times 4 is 4, and 1 times 4 is 4. So if I want to see if I've done this correct, these two are in series, so R2 is in series and R5 is in series. So these two, you add those two together, that should give you 8, and that should equal this one. So actually 8 volts. So this one here is 8, and this one's 8, because that's, you got 8 volts coming down this line. So these two resistors are sharing this 8 volts. So if we count that once, so that's 8, 8, 8. So we have 8 volts going down here, we have 8 volts going here, and 8 volts going here. So it's kind of like looking at this one here. We've got 8 volts here, 8 volts here, 8 volts here. And that's kind of what we've got right there. We've got 8 volts here, 8 volts here, 8 volts there. Okay? And then our last resistor, which is resistor number 4, is 4 volts. So 8 plus 4 is 12. So, and then we can just do Ohm's law to figure out our resistance total. So that's 12 divided by 4 is 3. So it'd be 3 ohms total. So that's how you would figure this one out. Like I say, this is, if you can get to a point where you can calculate a circuit like this, you're about 3 steps or maybe even 10 steps above where you actually need to be as an automotive technician. Because I'll give you a little commercial right here. I'll probably mention it somewhere else in one of the other videos. In my entire 30 plus years of working on cars, the only time I've ever used Ohm's law to calculate a circuit is when I was building a trailer and I needed to figure out what kind of fuses to use and stuff like that. But if you understand how electricity works through the circuit, like this, where the resistance is, where the voltages are, where the amperage is, it really does help in your diagnosis. So it's kind of giving you that extra sense of how to fix stuff. And so that's why I think this is important. But this is how you would calculate that one. So this is probably the most complex series parallel circuit that you will ever need to figure out how to work. So like I say, if you need any help or anything, just come and find me and I will be glad to help you out.